Bismillahirrahmanirrahim. Assalamu alaikum. My name is Jamshed Ali. My role ID is 190994. So today I'm gonna introduce you about the interfacing of LCD, liquid crystal display, and HEX Keypad with ATMEGA using ATMEGA Studio and Proteus. So first of all, the equipments we require: AVR Studio, Proteus, ATMEGA, LCD 16x2 breadboard and registers, and also potentiometer, etc. to print on our LCD any string. So first of all, this is the little bit introduction about LCD. It is used to interactive LCD provides textual information from microcontroller. So it is 16 cross 2 of LCD. LCD control unit is also the controller. So here is a little bit introduction. It is responsible for all the operations within LCD such as movement of cursor, display, clear, etc. So it has two major portions known as character generator ROM, character generator RAM. It contains predefined character fonts table and stores customized character the table display data RAM. Store display data presented in 8-bit characters. This is our LCD. Looks like in hardware form, and this is our symbols. VSS to be grounded, VCC main power supply, VE power supply to control the contrast. We are going to control the contrast with the help of a potentiometer. So RS is a register select. These are all the pins. So the D all the data pins and the L positive for the light. So LCD has two communication modes: 8-bit communication and 4-bit communication. So the in 8-bit communication, 11 pins of MC reverse has 8-bit pins of for LCD data pins D0 to D7, and 3 pins for LCD control pins, enable pins, and read write and register select RS is pin 4. So this is the LCD interfacing introductions little bit. So this is the main flow chart. Make proper connection of microcontroller to LCD, send command to initialize display and cursor, send the character to display on LCD. So these are all the commands used for different displaying, return norm, decrement, cursor, etc. for our LCD. So this is the character displaying on string displaying on LCD. This is a 2x16 line LCD display. So now we are going to make a clock by interfering 3 7-segment displays which show the hours, minutes, and seconds with ATMEGA 360. So now you can see this is our code which we are going to implement on our segment. So first of all, we have to include AVR standard, set frequency, and set the delay mainly identify delay, and then this is our main int function. Here we have unsigned character array of 1 2 3 4 5 6 7 8 9 and 10 mean 11 display. So A, B, C, D, E, and F are set as a output port with the help of our direction register. We are giving maximum value 255 to the A, B, C, D, and E, F, and set as a output port. While unsigned character S1, S2, M1, M2, and H1, H2 are the selection lines denoted as. So these are all set to the port A, B, C, D, E, and F. So here while loop begins, and for the first for loop begins where h1 is equal to 0, h1 less than 3, and then this loop will begins 3 times, and after it our array calls the first function, and then another second function will calls 2 times, calls 10 times. So after 10 times this function will return to the port E, and this array will print out, and after it our third function will calls 5 times, so from 0 to 5. So after it will calls to the port E, and then our next function will calls from 0 to 5 times, and as it is our port B function calls from 0 to 9 means 10 times, and with the help of some proper delay, this is all the functions of our second. So these are the seconds, minutes, and hours output. So these are our for the second function, and now we are going to move towards our minute function. So this will display the simple array of 0 0 which we are giving return after return. So this is our OR function. When h1 is equal to 2 and h2 is equal to 4, the function will break and the port E has a 0 output. So now this is the Proteus simulation of our clock using 7 segments. So now I'm going to show you the Proteus simulation on our Proteus. So now you can see here I am here running our circuit by exporting and by importing our hex files in Arduino ATMEGA 2560. So now my seconds are going increase, and our with the help of a 60 seconds there is a one raise in minute. So here I am calling delay of 0.1 seconds, so that's why it is too slow. When I am calling delay of some less than input, then our function will calls maximum time. So now I'm going to show you the second task, which we have to make a code in C to display Air University on 16 2x LCD using ATMEGA 3282560. So this is the basic code of our ATMEGA LCD. This is the header file of our LCD. So in header file, first of all, we have to set the frequency, standard AVR, delay, and with the help of controlling ports DDRC, data port DDRB, and with the help of data ports of the LCD. And after defining all the RS selection line, RW read write lines, and enable, we have to initialize the three functions: LCD in and LCD unsigned character data and unsigned character CMD. And this function is used to print out the character in our LCD. So the first function will call LCD CMD 0x38, and then with the some proper delay 0x01, and then with a proper delay 0x00, and this CMD function command LCD command function will calls one by one with the some delay, and then at last it will return. So in unsigned character CMD, functions will turn when RS is greater than read write the button, and then our enabler is 1. So in this case our port C will display CMD, and then with some proper delay, when our enabler is 0 in this case, then our delay, after delay, it will return to the previous value. So now this is the LCD data function. Here unsigned character, when enabler is 1, it will display data to the port C, and then if it enabler is 0, then it will return to the our function. So LCD string, here it I is equal to, when string I is equal to less than 0, then this is not equal to 0, then our LCD data print out string, and then within some increment, and then return to our function. So this is our main C file for printing our Air University or some other string on our LCD. So first of all, we have to include the header file, and then initializing the frequency and delay, and this is LCD11 header file which we are creating previously. So after creating header file, our main function DDRB, we have to set B and C port as an output port, and then with the help of LCD I and IT, we have to call some delay, and then with the help of this command LCD string, we are printing out Air University on our LCD. So this function will call CMD 0x05, and then with a proper delay it will call Air University 1 by 1. So now this is the Proteus simulation of our bringing of our appearing Air University on our LCD. So now I'm going to show you on the Proteus as well. Now you can see here, if I'm stopping this and again running this, you can see here Air University is printing on our LCD, because I'm here importing the hex file of our code which we are running from our ATMEGA Studio. So when we run the code, run the Proteus file, then Air University will print out. Now I am going to move towards our third task. So this is the hardware implementation of our task, and now I'm going to move towards our third task, which we have to make a small calculator using hex keypad and display the output on LCD. While in lab 4 we are printing the calculator output using hex keypad on 7 segments. Now here just we have to display output on the LCD. So the our code is mainly the same. So here we also have to define frequency, header files and data ports and read write ports, and then we have to declare the 4 output functions. So this is the main LCD functions which we are going to place in each and every code when we are writing our code in main file. So now this is the header file, and then now we are creating our header file which we are going to show on our LCD. So this is the input output direction register setting of and then after unsigning character distance r, we have to initialize the array, and then with the help of this IP context we are passing number 1 by 1. So when this it will detect temporary value 0x, then it will the function will break and it will jumps to the second number, and as it is in each row 4 numbers will appear 1 by 1. When we are pressing any of one of it, it will display on the Proteus or LCD which we are using 16x2. So 4 number and in this case it will jumps to the next row. So this is all the function, this is all the context which is using again and again for printing any of the input from the keypad. So this is the hex numbers, hex codes for our printing any of the number of the input. So after inputting all the inputs from hex keypad, we are going to print it out on our LCD. So this is the basic context which we are using again and again for our hex keypad as we are mentioned in lab 4. So this is the main code C file of our code which we are printing on our LCD. So first of all we have to initialize frequency, AVR standard and key. So these SMS, LCD and keypad are the two header files of our keypad and LCD. So this header file is used to print on LCD, while this header file is used to print getting input from the keypad. So keypad and LCD header files are created. Now we can easily print out any string on our LCD. So this is the we have initialized set temporary value, and then when q is equal to less than 10 and q is equal to 77, it will return to 1. So this is the basic code and which is we are using, and then with the help of main function we are using while loop and setting direction register and set port D and port E as a output port, and then with the help of ITA command we are printing and displaying even a string on the our LCD display. So if sign is equal to 44, then this is all the basic code for our simulating on hex keypad input. So after printing out this we are going to print it out on our LCD. So now this is our Proteus simulation of our hex keypad input, and it is printing on our LCD. So now I am going to show you the Proteus simulation here as well. So now you can see here when I am importing here hex file of calculator v02, and then okay, and then I am going to run our Proteus file. As you can see, if I have to play 1 plus 1 is equal to 2. So our calculator is giving us our correct value of 1 plus 1 is equal to 2. So this is our basic task to get input from the hex keypad, and we have to display it on our LCD liquid crystal display. So this is our hardware implementation as we mentioned in our lab. So this is our conclusion, that we are using LCD interfacing, and with the help of HEX Keypad we are printing out any calculator operation on our LCD and as well as 7 segment display. So these steps were actually concluded into 3 as well: a proper connection from microcontroller, initialize display and cursors, and then display the character. So this was the whole scenario upon which the whole code should work. Our code had worked successfully by the grace of Allah Almighty, Alhamdulillah, and we have done the task by ease and without any suspension or tension. So Jazakallah, that's all from my side. Thank you.